probability, let's look at this simple example. Toss a coin 5 times, the results are 2 heads and 3 tails. So the theoretical probability of getting a head is 1/2, but the experimental probability, use the result of the experiment, is 2/5. So you need to know the difference between experimental probability, which is based on the result of the experiment, and the theoretical probability are just based on a coin. There are 2 outcomes, one of them is a head. Okay, what is the expected number? Expected number of outcome is probability of the event times the number of trials. These are some of the formulas that you learn in year 9. So for example, if I throw a die 30 times, the number of times I expect to get the number 4 is, you do 30 times the probability of 4. What's the probability of 4? 1/6. So 1/6 times 30 is 5 times. So I expect to get 5 4s when I toss the coin 30 times. And the formula for probability is number of favorable outcomes over the total number of outcomes. So that's a simple formula for probability. Yeah, okay, good. So, all right, good. So this is good for one-stage experiment where you throw a coin once or toss a coin once. Then there's the table that helps you to list a 2-stage experiment where you do 2 things at once. So, for example, you select 2 letters from the word fun. So we're going to look at both cases of with replacement and without replacement. So when you select 2 letters, you have to divide into 2 parts. First, second, right? Your first letter could be either F, U, or N. Your second letter can be either F, U, or N. But let's use a different color so you can distinguish between them. So I'm going to use the color red. Both are like this. And then the other one is fun. Okay, first, and then the other one is second. Okay, like that. So with replacements is once you select the letter F, I could select F again. Okay, or I could select the letter U. I could select F. I could select letter N. I could select letter F, like that. Whereas the one without replacement means I could select the letter F, but I can't select letter F again because I don't put the F back. So therefore, in these instances, you can't have repeated letters. Okay, that's the difference between replacement and without replacement. Okay. All right, so once you know the key differences between them, let's finish off the listing of the outcomes. So U, N, F, F, and the second letter will be U, N, F, F, U, N, like that. And then just finish off the other ones. So you got F, E, U, N, F, 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 O. Oh no, made a mistake. Okay, U, N. Okay, good. And then I have this one. I have extra. Okay, so as you can see, the difference between them, there are 9 outcomes here. Right, there's 9 outcomes. Whereas this one, due to the exclusion, I only have 6 outcomes. So note the difference between without replacement and with replacement, they have a smaller sample size. Alright, good. So we got this thing. Probability. So there are 2 ways to list the outcomes. One way is to use the tables. The other way is to use the tree diagram. Okay? And this topic will look at probability tree diagram. We'll look at the case where They are with replacement and without replacement. Okay? Alright. Still recording, good. Alright, let me get started. So, blue. Okay, let's look at the tree diagram now. So, tree diagram. So, you select 2 counters from 3 white, 4 red. So, right. So, your first choice could be white or red. Your chance of getting a white is 3 out of 7. Red is 4 out of 7. Okay? And due to the fact they are replacement, your chance of getting white does not change. It still stays the same because we put the counters back. Again, no changes. It stays as 3 out of 7, 4 out of 7. And then I have the outcome. So the outcome you write WW, WR, RW, RR. And to calculate each of the probability, you have to multiply these probability together. 3 out of 7, 3 out of 7, which is 9 out of 49. And to calculate WR, you do 3 out of 7 times 4 out of 7, which is 12 over 49. And then to work out RW, you do 4 out of 7 times 3 out of 7, which is 12 over 49. And then to work out RR, you do 4 out of 7 times 4 out of 7, which is 16 out of 49. Okay, so that's how the probability tree diagram works, by giving you the probability of each outcome. Let's do the case where there is without replacement. Okay, have a try without replacement. You get very similar thing. You get WR. You get the same outcome, but with different probability. Okay. So be careful with your second choice. Your second choice is affected what you do in the first choice. Okay. All right. Let's fill this out. So your first choice will be still 3 out of 7, 4 out of 7. But be careful with your second choice. It's going to be out of 6 because you have one less counter to choose. You've already taken one counter out, but you do not put it back. So if I chose a white, there's only 2 white left, 4 red left. If I chose a red, there's only 3 red and still 3 white left. Okay, and the outcomes are the same, but with different probability. Okay, so you get W like that. And then to calculate the probability, you multiply this by that. So you get 3 out of 7 times 2 out of 6. You can simplify. 1/3, you get 1 out of 7. Okay? And this one, you get 3 out of 7 times 4 out of 6. You get 2/3, you get 2 out of 7. And 4 out of 7 times 3 out of 6, you get half. So you get 2 out of 7 as well. And 4 out of 7 times 3 out of 6, you still get 2 out of 7. Is that right? Yeah, it was right. You have to add up. So now another thing you need to note that if you add up everything here, if you plus them all together, what do you think the answer should be? 1. Yeah. Just so if they don't add up to 1, means that you must have made a mistake somewhere in your multiplication or in your probability. They must add up to 1. Okay? All right, that's a good way of checking. And of course, if you add up this one, it's going to be 1. But if you add up this one, it's 1. Add up this one, it's 1. But if you add up everything here, it's 1. All right, good. Okay, now there's a lot of summary. It's a big topic, so I've got 3 more pages to go through. There's a lot of diagrams you're going to fill out, which we're going to fill out together. So we've got the tree diagram. We've got the probability formula. We also have the Venn diagram and the two-way table. These are quite interesting as well. And it's quite visual. We can actually visualize what each of these symbols mean. On the Venn diagram, let's do them. Okay, we've got the union. Union means A or B. A or B means that everything in A and everything in B. That's what, actually, let's use a highlighter because I don't have to go. Let's choose a color. Oh no, that's the highlighter. Let's choose blue, purple. Alright, good, like this. Okay. Okay, good. Maybe choose a bit thinner. Okay, good. Alright, that's A union B. A intersect B will be the one in the middle. Okay. Oh. Why does it go like this? Okay, anyway. Alright, A intersect B means has to be A and B. Alright, A only, which is characterized by, let me get my pen. A only means A intersect with not in B. So it's in A but not in B. So to characterize this, go back to my highlighter, you just go this bit. Oh. No. Let's try again. Okay, good. Just A. And then I'm going to clean this up by clean up properly. Anyway. I'm not good at coloring in. Let me get thinner one. It's alright, you all understand what that means? Sorry. Okay, A only. No, I was having fun, I'm joking. Alright, good. Next one, complement of A is not in A. So not in A will be everything outside of A. Everything outside of A. I'm going, oh yeah, I forgot to write the letter. Let me write the letter there. I should have wrote the letter A. That's A. And then go back to the highlighter. Good. Outside of A. Okay? Okay, mutually exclusive means that they have nothing in common. Means that, oops. Means that there's nothing in common. So the intersection, this one means the null set. Null set means the empty set. Means there's nothing there. Okay? Alright, so they have nothing in common. As you can see, they don't intersect. Which means that if I write the probability of A and B is equal to 0. That is mutually exclusive. They got nothing in common. Alright, good. So we looked at some of the visual representation using Venn diagram to represent any of these. Of course, there's any other ones, you can also use the Venn diagram to help you. Okay, after we do this, let's look at the connection between the Venn diagram and the two-way table. Alright, good. Continuing on. Okay, let's look at the first one, Venn diagram. Okay, two-way table. What's their connection between them? Very easy to connect them. Okay, alright, so this is what you do. This number here means 2 is that both A and B, right? This 2 there, right? And then the next one in B, not in A. This is B only. B only is 5, right? That means this is B only. And the A only is 4, not in B, in A. A only. And then finally, 1 is the one not in A, not in B. And then what you need to do is to find a total. So 2 plus 5 is 7. 2 plus 6, 2 plus 4 is 6. 6, 5, and 4. Okay. All right. Only question. Okay, and then we can go backwards. Starting with the two-way table, we can write things on the two Venn diagram, which is also very easy. So that's in both A and B. This one is in B, not in A not in B, and that's in neither A or B. And then you can maybe the total I'll leave you to work out. Actually, I should work them out. It's not that hard. 7, 4, 11, 3, 8. Okay, done. All right, now we know the difference between them, how to convert one to the other. We've got 2 more pages to go through, then we'll finish. Okay. All right, all done. Let's move on. Addition rule. There are some algebra involved in this topic, and this is a formula that you're going to use. Very important rule. This rule, you have to memorize. It's not hard to memorize, okay? Very easy. So if it's mutually exclusive, then the intersection will be 0. Therefore, this formula will become PA plus PB. Because they got nothing in common, you don't have to subtract by the intersection. Okay? All right. And then we're going to do some example of that with this formula. Select a card from a standard deck. Remember, there are 52 cards. And probability of red or ace, you can use the formula probability of red plus probability of ace minus probability red and ace, because they are not mutually exclusive. They are not mutually exclusive, so you have to subtract by their intersection. So how many red are there? There are exactly half of them, right? So 26 out of 52, or half. Ace, there are 4 aces out of 52. And which one are red aces? How many? 2 out of 52. So you have to subtract them. So what do you get? 28 out of 52, which is, you divide by 4, you get 13. Yeah, come in. Must be the challenge. Come in. All right, come in. I don't think it's locked. Yeah. Yeah. All right. Yeah, thank you. Thank you very much. Oh, thanks. All right. Okay. After this, let's continue. So this is a case where it is not mutually exclusive. Exclusive, not. And we'll look at the case where they are mutually exclusive. Is ace and king mutually exclusive? Can a card be both ace and king at the same time? No. So it's actually mutually exclusive. So when it is mutually exclusive, you can actually do that's equal to probability of ace plus the probability of king. But you do not need this because it's 0 anyway, right? So probability of ace will be 4 out of 52. King is also 4 out of 52. So it's 8 out of 52, which is 2 out of 13. So note the difference between them when you have a mutually exclusive and non-mutually exclusive events, and how to use this important formula. All right, all done? Thank you. All right, let's move on. Conditional probability. These are the 2 formulas. Probability of A given B is how many in both A and B over how many in B. You can change that, the n, the how many, into a probability. This also works. We're going to use that formula. Okay, listen. Let's use the formula. Okay. Okay, using the first formula, A given B means how many in A and B over how many in A in B, right? Just think about A given B is A over fraction B, right? Think of it this way, then you understand why you divide by how many in B. So how many in B? There are 11. How many in both A and B? There's 5. So given I know the person, it's Blueberry, Out of those who eat blueberry, which is 11, there's 5 also eat avocado, right? That's using the first formula. We can also use the second formula, which is the one on the top here. You can change the n to probability. Sometimes this could be useful due to the information you were given. So you get the same thing. Probability of B is 11 out of how many altogether? 5 plus 6, 11, 18, 20, right? It's out of 20. And then there are 5 out of 20. And if you divide them, the 20 get cancelled. That's why it works. So the answer is going to be 5 out of 11 as well. Okay, so there are 2 ways to do that. One more page, then we're done. We'll finish summarizing probability. You should watch the video again so that you can get better and revise before the test. One more bit. For this, I don't know. But you need to get ready anytime. One more page. Continue. Thank you. All right. 2 events, A and B. We just did exercise 3G. 2 events are independent. There are 3 ways of doing. Either prove A given B is probability of A, or show that the intersection of probability is equal to the product of these 2 probability, or you can show probability B given A is probability of B. Okay? So there are 3 ways of checking independence. 3 formulas. So as an example, on independent event, given I have selected an ace, what's the probability that the ace card is a red card? Well, there are 4 aces, and there's 2 reds, so it will be 1 out of 4. What's the what's a half? Yep. And then we're going to find the probability of red. Now, the probability of red is a quarter, right? Are they independent? They are not, right? Red and ace are not in. Therefore, probability of red given ace. Oh, yeah, they are independent. Oops. Red and ace are independent. No, 2, sorry, it should be 26. 26 out of 52, which is a half. Yep, they are independent. So right there, for red and ace are independent of each other. Red and ace are independent. Okay, good. Now there's another way which I showed you before. Find the probability of red and ace. This is finding how many cards that are both red and ace, which is 2, right? 2 out of not 4 will be 52. Because it's not conditional. See, when it's conditional, we have a smaller denominator. This is red and ace in a 52 card deck. So it will be 1 out of 26. There's only 2 cards that are red and ace. Yep. Yeah, not red or ace. Okay. This one, red times ace, will be red is half. Ace is ace will be 4 out of 52, right? Which is half times, which is, what would that be? Half times 1 over 13. You get the same thing, isn't it? So you say, therefore, probability of red and ace is equal to probability of red times probability of ace, right? Therefore, A, R, and A are independent. So there are 2 ways of doing that. Obviously, the first way is quicker. So this is method 2, and this is method 1. All right, good. Means that they don't affect the result. They don't affect each other's result. Well, sometimes if you know they're independent, they won't blame the other event, if you know what I mean. It's not, yeah. No, if there are reasons, it means that they're independent of each other. They're independent, as in, it doesn't affect. Yeah. So where the events are not independent, which is dependent. So probability of A given B. So given we know it's an odd number, how many odd numbers on a die? 3. Out of the 3, how many are less than 4? Less than 4, 3, right? Less than 4 means 1, 2, 3, right? 3. Oh, no, 2. Oh, has to be odd. Sorry. Given it is odd, how many are, yeah, you're right, 2. So 1 and 3, 5, then it's 2 out of 5, 2 out of 3. All right, what's the probability that the number is less than 4 will be 3 out of 6, isn't it? Which is half. So you say, therefore, they are not the same. So you say, therefore, A and B are dependent or are not independent. Not independent. Okay, good. All right. Okay, this is the last bit. We'll do calculation. Then we'll have a final summary of all the formulas. Let's write them all here. Okay, we're going to write down all the formulas. Okay, so let's do that. So first one, probability not B is probability 1 minus probability of B. 1 minus probability of B. Let's do it in blue pen better. 1 minus the probability of B. And A or B is probability of A plus probability of B minus probability of A and B. Yep. Yeah. Okay, next one. I don't know why I have these ones. Yeah, I forgot what I'm going to write. Don't know why I put two. But anyway, let's do this one. Probability A given B is probability of A and B over probability of B. This one is probability of A and B over A. Yeah. I think what I'm trying to do is that probability A and B is probability of A times the probability of B if independent. But if it's not independent, then you have the probability of A times probability of B given A. I think that's what I'm trying to write, I think. And then finally, two events are independent if probability of A given B is equal to the probability of A. Or the other method is just to prove A and B is equal to probability of A times the probability of B. This is the summary, so let me draw a box around it. Make sure you look at this formula. Thank you. We'll spend half an hour on that. Then you have to do catch-up work today, and we'll start new topic.